A very good day to our lecturer, Dr. Azizi. Today we would like to present about topic 9, hypothesis test for one population mean. Our group members included Sim Yuan Chin, Fu Meng Tao, Gi Hui and me, Cheng Xian Yen. First, I would like to present the nature of hypothesis testing. Hypothesis is a premise or claim that we want to test. A hypothesis is a statement that something is true. For example, the mean age of the students in class are more than 20 years old. Hypothesis test is separated by three hypotheses, that is null hypothesis, alternative hypothesis, and hypothesis test. Originally, the word null in null hypothesis stood for no difference. However, null hypothesis has come to mean simply hypothesis to be tested. A null hypothesis is a claim about a population parameter that is assumed to be true until it is declared false. An alternative hypothesis is a claim about a population parameter that will be true if the null hypothesis is false. This is null hypothesis formula, and alternative hypothesis separated by three types, that is two-tailed test, left-tailed test, and right-tailed test. After we have chosen the null and alternative hypothesis, we must decide whether to reject the null hypothesis in favor of the alternative hypothesis. The procedure for deciding is roughly as follows. Any decision we make based on a hypothesis test may be incorrect because we have used partial information obtained from a sample to draw conclusions about the entire population. There are two types of incorrect decision, that is type 1 error and type 2 error. This is type 1 and type 2 errors table. Type 1 error rejecting the null hypothesis when it is in fact true. Type 2 error not rejecting the null hypothesis when it is in fact false. Relationship between type 1 and type 2 error probabilities. For a fixed sample size, the smaller we specify the significance level A, the larger will be the probability B of not rejecting the false null hypothesis.
Hi, my name is Sim Yuan Chin. Today I'm going to explain about the hypothesis test for one population mean when standard deviation is known as a large sample. With the critical value approach to hypothesis testing, we choose a cutoff point based on the significance level of hypothesis test. The criterion for deciding whether to reject the null hypothesis. They divided into three, that is, rejection regions, non-rejection regions, and critical value. Hence, if the value of the test statistic fall in the rejection regions, reject the null hypothesis, otherwise do not reject the null hypothesis. Next, distributions of the standardized test statistics and the rejection regions. For the two-tailed test, the null hypothesis is rejected when the test statistics is either too large or too small. The rejection regions consist of two parts, that is, on the left and on the right. For the left-tailed test, the null hypothesis is rejected when the test statistics is too small. The rejection regions only consist one part, that is, on the left. For the right-tailed test, the null hypothesis is rejected only when the test statistics is too large. The rejection regions only consist one part, that is, on the right. Next is the sign in alternative hypothesis rejection regions. However, because of the central limit theorem, the one-mean z-test will work well when the sample size is large, regardless of the distributions of the variables. The test statistics for one-mean z-test is sample mean minus null hypothesis and divided by standard deviation that divide the square root of number item in the sample. Next, one-mean z-test critical value approach. To perform a hypothesis test for a population mean, we have to make sure that it's a simple random sample, normal population or large sample, and standard deviation is known. Furthermore, step the test procedure for a test of hypothesis concerning a population mean when the sample size is large. Step 1. If the null hypothesis is mean equal mean hypothesis, we need to decide the alternative hypothesis whether it's two-tailed, left-tailed, or right-tailed. Step 2. Decide on the significance level, that is alpha. Step 3. Compute the value of the test statistic. Step 4. Use table 2 to find the critical value. Step 5. If the value of the test statistics fall in the rejection region, reject the null hypothesis. Otherwise, do not reject the null hypothesis. Step 6. Interpret the result of the hypothesis test. Remember, the hypothesis test is exact for normal population and is approximately correct for large sample for non-normal population. When to use the one-mean z-test? For small samples, size is less than 15. For moderate sample, size between 15 and 30. For the large sample, size 30 or more. For the small sample, the z-test should be used only when the variable under consideration is normally distributed or very close to being so. For sample of moderate size, the z-test can be used unless the data contain outlier or the variables under consideration is far from being normally distributed. For the large sample, the z-test can be used essentially without restriction. Hence, if outliers are present and their removal affect the conclusion, use a different procedure or take another sample. On the other hand, if outliers are present but their removal is justified, the procedure can be used. For example, the mayor of a large city claimed that the average of families living in this city is at least $300,000. A random sample of 100 families selected from this city produced a mean of $288,000 with a standard deviation of $800,000. Using this 2.5% significance level, can you conclude that the mayor claim is false? Step 1. For the null hypothesis, mean is at least $300,000, and for the alternative hypothesis, its mean less than $300,000, that is $288,000. Step 2. The significance level is 2.5%, or we can write as alpha equals 0.025. Step 3. Compute the test statistics by using the formula and the data given. Step 4. The sign less than in the alternative hypothesis indicates that the test is left here. Hence, from the table 2, critical value is equal to negative 1.96. 5. The value of z from step 3 is equal to negative 1.50. It is larger than the critical value. It falls in the non-rejection regions, hence do not reject the null hypothesis. Step 6. Interpret the result. Hence, the answer is, at the 2.5% significance level, the data provides sufficient evidence to conclude that the mean of families living in this city at least $300,000.
P-value approach. With the p-value approach to hypothesis testing, we first evaluate how likely observation of the value of them for the test statistic would be if the null hypothesis is true. The criterion for deciding whether to reject the null hypothesis involves a comparison of that likelihood with the specified significance level of the hypothesis test. The p-value of a hypothesis test is the property of getting sample data at least as inconsistent with the null hypothesis as the sample data equal of 10. We use the letter p to denote the p-value. Small p-values provide evidence against the null hypothesis, but larger p-values do not. Decision criterion for a hypothesis test using the p-value. If the p-value is less than or equal to the specific significance level, reject the null hypothesis, otherwise do not reject the null hypothesis. To obtain the p-value of a hypothesis test, we assume that the null hypothesis is true and compute the probability of observing a value of the test statistic as extreme as or more extreme than that observed. For two-tailed tests, the p-value is the property of observing a value of the test statistic z, which is the area under the standard normal curve that lies outside the interval from negative z0 to z0. For left-tailed test, the p-value is the property of observing the value of the test statistic z, which is the area under the standard normal curve that lies to the left of z0. For right-tailed test, the p-value is the property of observing a value of the test statistic z, which is the area under the standard normal curve that lies to the right of z0. To perform a hypothesis test for a population mean, there are some assumptions that is simple random sample, normal population, or large sample, and the standard deviation is known. These are steps when using p-value approach to hypothesis testing. Let us see the example when using p-value approach to hypothesis testing. This is the solution for example 1.
Hello everyone, my name is Fu Meng Tao and today I'm going to explain about the hypothesis test for one population mean when the population standard deviation is unknown for a small sample. We can perform a hypothesis test for a population mean when the population standard deviation is unknown by proceeding in essentially the same way as when it is known. The only difference is that we invoke a t-distribution instead of the standard normal distribution. The t-distribution is used to conduct a test of hypothesis about a population standard deviation if 1. The sample size n is less than 30, 2. The population from which the sample is drawn is normally distributed, 3. The population standard deviation is unknown. For a test with null hypothesis, population mean equals to a specific value. The test statistic t is calculated using the following formula, where t equals to the sample mean minus the population mean divided by the sample standard deviation over the square root of the sample size. This hypothesis testing procedure is called one-mean t-test or simply t-test. There are two types of approach we can use for this procedure, which is the critical value approach and the p-value approach. The steps are summarized as follows. Step 1. State the null hypothesis and alternate hypothesis. Step 2. Decide on the significance level. Step 3. Compute the value for test statistic t. Critical value approach version of step 4. Determine the critical value using the statistical table 4 with pf equals to n-1. For the p-value approach, estimate the p-value using statistical table 4 with pf equals to n-1 or obtain the exact value by using technology. Step 5 of the critical value approach. Reject the null hypothesis if the value of the test statistics fall within the rejection region. Otherwise, do not reject the null hypothesis. For the p-value approach, reject the null hypothesis if the p-value is less than or equal to the significance level. Otherwise, do not reject the null hypothesis. Last but not least, for the final steps of the one-mean t-test, interpret the results of the hypothesis test. Thank you for watching. That's all for today.